Welcome, Hornets, and thank you for joining me today. Today, we're going to be taking a look at classwork number 7, which is found on particular solutions number 1, and this is from section 6.1. So up here, I'm going to be doing the even problems, at least a couple of them, just so that people can see how to do things, and if you have questions, that we can get those questions answered. So let's go ahead and begin. We're looking at our first question, dy dx equals 2x squared over e to the 2y power. Okay, I'm going to take this off to the other page, and I'm going to do it on the whiteboard here. And I'm going to start by writing my equation out. What is the problem? And I like to go ahead and do the first 3 steps for our differential equations that we have. And that is to first write it down, then separate your variables, and then integrate. Now, once we get here, please be aware if we do use a u substitution, it's going to give us a 1/2. So we are looking at 1/2 e to the 2y, and this will give me 2/3 x cubed plus c. Now I'm going to multiply both sides by the 2. So I have e to the 2y is equal to 4/3 x cubed. And just because we multiply c by 2, it just makes a constant again. I'm now going to exponentiate. Natural log of e, 2y comes to the front. And this is giving me the natural log for the absolute value of 4/3 x cubed plus c. Since the natural log of e is 1, we're looking at 2y equals the natural log of the absolute value of 4/3 x cubed plus c. And I'm now going to divide by 2. This will give me the natural log of 4/3 x cubed plus c divided by 2. And this is now my answer. That's the answer to number 2. Let's go ahead and take a look at number 4. Here's number 4. You'll notice in number 4 we have dy dx equals 2e to the x minus y. So that's what we're going to work on. Let's go ahead and take a look at it first. And I'm going to start by writing down the information. Dy dx is equal to 2e to the x minus y. Now, notice this minus y. We're going to have to rewrite this so that we get it into the appropriate orientation. It's actually e to the y in the denominator. And this is necessary for me to now go through process. So here we go. We're now going to separate our variables. E to the y dy is equal to 2e to the x dx. And we're going to integrate e to the y dy equals 2 integration e to the x dx. This is going to give me e to the y equaling 2e to the x plus c, and I'm going to have to exponentiate. So the natural log of e, y moves to the front from my laws of powers, and I have the natural log of 2e to the x plus c. Now I have absolute values around mine. That's because I don't know whether that constant is going to be positive or negative, and I'm just kind of covering my butt, okay? Trying to make sure I protect myself in case something happens. I'm now going to get rid of the natural log of e, and I am left with my answer. Once again, some people might write it with a parentheses, others might write it with an absolute value. I prefer the absolute value simply to make sure that I don't make any silly mistakes. Next, we're going to be going to number 6. Now, number 6 is giving us dy dx equals xy squared, but now they want me to find a particular solution, so we have to find what c is, and to do that, I'm going to use the point 1 negative 3/2. Negative 2/3. Okay, so here we go. We're going to start by writing our equation down. Dy dx is equal to xy squared. We're going to separate our variables. 1 over y squared dy equals x dx. And I'm then going to integrate y to the negative second power dy equals the integration of x dx. I'm going to get negative 1 over y equals 1/2 x squared plus c. And now this is where we start to kind of get a little bit interesting. In order to get a common denominator, I have to multiply my constant by 2. But if I have a constant and I multiply it by a scalar of 2, it's still a constant. So what we're allowed to do is say negative 1 over y is equal to x squared plus c divided by 2. Now I can take the reciprocal of both sides. Negative y equals 2 over x squared plus c, and then multiply by the negative to give me y equals the negative fraction 2 over x squared plus c. And that's my answer to number 6. Let's go ahead and take a look at our last problem. This one is number 8. Number 8 is giving me dy dx. I'm going to write it down. Dy dx is equal to x over y squared. Oh my, I forgot to find my constant. Well, gee. I'm going to take my point and I'm going to plug in. Negative 2/3 is equal to negative 2 over 1 plus c. Notice I put my 1 squared in. And the obvious answer is that c has to equal a 2 in order to get a 3 in the denominator. That means that my equation should be negative 2 over x squared plus 2. And that's the final answer for number 6. Once again, sorry about that. I forgot to plug in the value. Here we go. Number 8. This is our last one that I'm doing for the classwork. Here we go. I'm going to separate my variables. Y squared dy equals x dx. I'm going to integrate y squared dy equals the integration of x dx. I'm going to add 1. This is giving me 1/3 y cubed equals 1/2 x squared plus c. Now they've given us a point. The point was negative 2, 2. And so I'm going to plug in the negative 2 and 2 now. This is giving me 8/3 equals, what's that going to be? Positive 2 plus c. And that's going to give me 2/3 equals c. I'm going to put that right back in so that 1/3 y cubed is equal to 1/2 x squared plus 2/3. I'm going to multiply by the 3 on both sides so that y cubed equals 3/2 x squared plus 2. And then I'm going to take the cubed root on both sides. This gives me y equal to the cubed root of 3/2 x squared plus 2. And that's my answer. Alrighty, so that's my classwork, the evens that I said I would do, and I hope this has helped. If it has, please click like. If not, please give me a comment so I know how to improve. Thank you very much, Hornets. Please be safe, take care, and have a very good evening. Good night.